So we've got this is our agenda. I'm going to give a little introduction in a minute to some of the sort of big challenges and opportunities around cities, regions and IoT. And then my colleague, Dr. David Scott, will give an outline of what we've been doing in the Smart Cities theme as part of the Pitching project and what Pitching was trying to achieve. And then we've got a little showcase, a set of lightning talks on some of the projects that have been funded through Pitching, and gives you a flavour of some of the research that's been going on this theme. And we'll have a little Q&A session towards the end, time depending, and finally we'll finish off and summarise and try and finish very promptly at 15:30. So it's always really hard when you're asked to do a big picture thing around cities, because cities are these hugely complex organisms of intermeshed systems that are colliding and clashing all of the time. So what I've tried to do is just from what we've been doing at Newcastle and across the other universities around Pitching and other projects is try and address some of the challenges that IoT in particular faces, and also push some of the opportunities that we have. Next slide, please. So we start a talk about cities by talking about things as far away from cities as we can. We're talking about extrasolar planets. And the reason I include this here is I think we're on this cusp, and IoT is driving that innovation. We're on a point where the graph suddenly starts to go upwards. And many other fields of science have shown the same things happening, where suddenly new technology, new methods have absolutely kick-started a data and subsequent scientific and engineering insights. So in the case of exoplanets, new technology that came around 2014 has developed. So suddenly we've gone from only being able to find a few of these to be able to find thousands of them. In fact, they were in the news last week. Next slide, please. The same goes across other disciplines. This is sampling of genomes, whole genomes. And as you can see, there's this, we go on for many years on a very flat thing, and then suddenly there's this huge increase in the amounts of genomes that we're able to sequence. And where we are right now with cities is we're at that inflection point. We're right at that inflection point. And it's being driven by things like the Internet of Things. Cities all over the world are investing in smart city technology. And from those IoT devices connected to the internet, transmitting information 24 hours a day, 7 days a week. They're looking to optimize their systems. But actually, for us as researchers, the data explosion potentially enables us to develop whole new insights that were completely not possible before, because this is a complete paradigm shift in data and how we acquire it. Next slide, please. And this is an enormous opportunity. And it's an enormous opportunity commercially, and that's what many people are looking at the moment, is how do we exploit these communication networks, the miniaturization of sensors, the ability to be able to transmit, store, and in some respects, analyze through AI and machine learning these vast amounts of data. So if you troll the internet, as I did here for this graphic, there's lots of these enormous numbers. $820 billion worth in this IoT market by 2025, which is approaching with far too rapid a speed, in my opinion. There's enormous opportunity economically and financially. The question for me is more about what's the opportunity for society and can we grasp it? And I think that's a bit of a thornier issue around the Internet of Things and cities. How do we turn all of this data into something that benefits society, improves social justice, reduces inequality, levels up? How do we do that with the Internet of Things? So over and above that economic challenge, how do we use this as a force for good? Next slide, please. This is a study that was done in 2018 on autonomous vehicles. So it asked a large number of participants about what the likelihood of some of the things that autonomous vehicles are going to do, such as capture images, recognize individuals, track individuals, recognize vehicles. So how likely was that to happen? And also then how comfortable they felt with this. And I use it here as just as an illustration of, on the horizon, we have some of these black swan events that are going to happen and really perturb the way we think about data in cities. So autonomous vehicles that are continuously collecting huge amounts of information, potentially talking to other vehicles electronically and transferring and transmitting that information. There are a number of these technologies that are going to be coming on stream in the very, very near future, and they are going to perturb things as well. Against that, we have some of the massive issues around climate change and net zero that we're trying to achieve in cities. So there's potentially some perfect marriages here of how we combine technology and these new paradigm of data with some of these massive societal challenges. So there's an opportunity there that's really interesting. But there's also a danger, and I think the danger here is apparent. Lots of people are very uncomfortable with the idea of a surveillance society. And when we start talking about monitoring and observing cities and all of this sort of things, that is instantly one of the things that we have to deal with. Next slide. So this is some work by my colleague, Tom Komar at the Urban Observatory, who'll be talking a little bit later about some other work. And what this is, just to explain it, is real CCTV footage that has then been analysed through machine learning and artificial intelligence. That's a very sweet couple holding hands there, to extract the movement data from the image and then replace the persons themselves with just the stick figures. So the information that's critical to understanding, movement around cities and how people interact with objects, even whether our cities are suitable for people who are infirm and old, is still there, but there's nothing that's personally identifiable. And I use it here just to sort of, that challenge around cities is we need to collect information. We need to collect data to understand them. And we have to collect information that's sometimes really hard to collect, like pedestrian movements and things like that, that is potentially personally identifiable. But we need to use technology in a way that we can manage the privacy and bring society along with us as we're making these changes. So questions, I think many people would be on board with the idea about using this type of smart city data for the public good, if there were enough checks and balances in there about who owns the data, for what purposes is it going to be used, whether we can ensure privacy and protection like the use of this sort of technology with video and AI. And these are big challenges moving forward, as we've seen. If you get it wrong, as they did in Toronto with the sidewalk, Google Sidewalk Labs, you have a backlash. And we need to be careful about that in cities. We need to do this in a way that's acceptable and have privacy and security at the heart of what we do. Next slide, please. One of the dangers that's become very apparent to many of us working in this sector is the way in which the tech companies, if you like, approach data. Many of these look as data as a valuable resource that they can further mine for profit. And I'm not saying that's a bad thing, because our systems need to be profitable. But what that danger is that we end up with a massive number of silos that are inaccessible, and we can't get at that data. And the analysis is another service that's thrown on top of the infrastructure as another way of extracting money from the customer, in this case, the taxpayer. And the example here is that Newcastle was one of the DFT's test site for these e-scooters. And part of that agreement is to provide data and access, so that we can understand that and use it in conjunction with the other cities, with the other data streams that we have here in Newcastle. So how do people use e-scooters, and how do they interact with buses and trains and other modes of transport? All of that's really interesting stuff. But the moment this is siloed off and you can't access it, you can't start understanding the nuances. And there's no ability to layer data on data and extract information from it. There's also the issue that we lose that data forever, because if there aren't archives of it, if we want to go back and analyze things historically, we've lost it forever if we're not in control of it and it's not being publicly archived. And we can't have public scrutiny of the data if it's hidden behind commercial systems and it's inaccessible to us, the citizen, or the customer, or the person on the street, or the researcher. So I think these are dangers around siloing of this information. And I don't have any easy answers as to how we solve that problem. I just flag it as an inherent danger of what we're doing. Next slide. Now, many of you, there was an article the other day from the BBC around smart cities. So our National Cyber Security Centre, which is part of GCHQ, and the security services in the UK have recently, as in last week, published cybersecurity principles for connected places. One might question whether this is a few years late, given that we have connected traffic lights and many connected systems already, but at least it's a step in the right direction. And I think how we address cybersecurity, particularly when we have connected systems, so charging systems for EVs, for instance, which are connected to smart grids. All of these systems are interconnected. So there's the attack surface in smart cities is absolutely massive. There are so many places where you could get an in. And also, I suppose we're not just talking about Italian job style messing the traffic lights in Turin or Milan, I can't remember which one it was, to rob a bank. It's also things like, well, if we're using IoT for statutory regulation, then if you have a man-in-the-middle attack changing those values, it's completely useless. So it doesn't necessarily have to be these huge attacks. They can be insidious and small, and we still need to address them. Next slide, please. Oh, sound's off. Is there any way we can turn the sound on? Oh, thank you. So one of the things that really sort of gets my goats with smart cities is this idea that is sort of, no one says it outright, but this idea about sort of these clockwork cities, which this video is a sort of made up example of, that we can organize with all of this data things so that they move They run incredibly efficiently and we can optimize everything. You know, that's an absolute laugh, frankly. It's never going to happen. We can't optimize. They're messy human systems and Victorian sewers. And, you know, it's just not a system that you can optimize in that way. But I do think what we can do with this sort of data is we can start thinking about how do we be smartly inefficient? How can we be inefficient in a clever way to drive society forward in the way that we're trying to do it? So can we use it to nudge behavior, for instance, be smartly inefficient? What about new types of decisions that we could never make before? So typically in cities, we have legislation that's passed and it sits there and it does something for 3 or 4 years. IoT and this new type of data potentially enables us to make very agile decisions, data-driven decisions. And there's a lot of talk coming out of Number 10 and central government about being agile. And we've shown through COVID that we can be more agile in our response. And it could be fueled by this sort of data. Next slide, please. And my final sort of plea out there is really that the Office for National Statistics says there's 112 major cities and towns in the UK. That's defined as more than 75,000 people living in them. And how many of those have smart city initiatives? Well, I'd guess at somewhere in the region of 112. And probably other smaller places as well. The problem around cities is at the moment, it's a bit of a free-for-all. And, you know, how do we share data? How do we collect it? How do we curate it? How do we compare Newcastle with Sheffield, with Bristol, with Toronto in terms of all of this? Now, that's not to say there aren't standards emerging around some of the tech, but the tech is different from the sort of curation and how we deal with it. And we're in danger of having 112 smart city systems, none of which talk to each other in any shape, form, or size, because we're dealing with cities individually and not thinking about this at a national or an international level. Next slide, please. And finally, my last point is that there's lots of great small wins as well as solving climate change and net zero, which obviously IoT is going to do. There's loads of great small wins in there. And I give you as an example, the project that we've been working on in Newcastle, which is around pedestrianisation of Blackett Street, which normally looks like that, full of buses, chucking out diesel fumes. It runs smack through the centre of Newcastle. And we've been working with the City Council on pedestrianisation of that and capturing data on the impacts of it. And do you know what? We've used IoT to do that. And what we've found has been not very surprising. If you take diesel buses off the roads, air pollution gets a bit better in that area and is slightly displaced somewhere else. It gets slightly worse somewhere else. If you make buses do a slightly longer journey, then bus journeys are increased slightly by a few seconds on average. And if you make places nicer places to be, more people go there and they stay for longer. It's not groundbreaking, all of those. We could have guessed at all of those, but what IoT gives us is the ability to quantify those. So I can tell you that it's 12 seconds that bus journeys increase on by average. And air pollution was displaced by X, and we had this many more people on the street. And that ability to quantify things gives decision makers the ability to say things and to counteract often the people who say, well, we don't want to change it because we like the status quo. That ability to quantify is quite important. So there's lots of small wins out there. And I've managed to go slightly over time, despite promising not to. So I'm going to stop there. Okay, so I'm going to hand over now to my colleague, David Scott, and he's going to give us a little bit of a background into the pitch-in programme and the smart city theme. David, over to you.
Thank you, Phil. Next slide, please, Elizabeth. Okay, so today I'm just going to give, as Phil said, a very high-level outline of the pitch-in programme. So I'll describe the programme, I'll describe some of the mini projects that we'll hear about later on today, tell you about some of the industrial partners and disciplines that have been involved in the projects, talk about some of our work on barriers to adoption of IoT, then just give a summary at the end. Next slide, please. Okay, so pitch-in, probably some of you wondering what pitch-in stands for. Well, if you read the words on the left, it's about promoting the Internet of Things via collaborations between HAIs and industry. So HAIs, universities, industry, we use it within pitch-in. To me, it's a catch-all phrase, meaning an entity that isn't a university. So it could be a hospital, a local council, it could be manufacturing industry, a government agency, what have you. So promoting the Internet of Things. So we're promoting the adoption of IoT via collaborations between universities and industry. And if you look on the right, you will see a couple of columns there. So we have 4 major themes. Smart cities is one of them. The others being health and well-being, energy systems, and manufacturing. And Phil's the lead for smart cities out of Newcastle, but we do work very closely with the other universities who lead on the other themes. We also have a theme introducing so managing the introduction of IoT, which is a cross-cutting theme. Next slide, please. Okay, and again, this just summarizes what I've just said. We're looking at collaboration to identify and address barriers to the development of IoT. Next slide, please. Thank you. A word to our sponsors. We're funded by Research England as part of the Connecting Capability Fund. So thanks to them for funding us. Also, thanks to them for their flexibility during the COVID pandemic periods. We've had to reprofile some of our projects, so they've been very flexible there. So thanks to them for that. As I said, there are 4 universities, Sheffield, Cambridge, Newcastle, and Oxford. Sheffield are the overall lead. They also lead on healthcare, Cambridge on manufacturing, Oxford on energy. And Phil leads on energy, smart cities at Newcastle. At the core of what we do are mini projects where we test how barriers to the adoption of IoT can be overcome. And we work very closely with industrial partners on these projects. We funded about 60, and you'll hear about half a dozen of them today. Next slide, please. Right, so these are the projects that we funded within the Smart Cities theme. You'll hear about most of those today in terms of air quality monitoring, computer vision, radio frequency systems in smart cities, urban flow analytics, and smart cities data. Some of the projects you won't hear about have been focused at Oxford, for example, on green spaces for mental health and also on biodiversity. So what we've looked at here is how the urban and rural environments affect people's mood and therefore their well-being. So there's a very strong interplay there between the environment in which people live and work and their mental health. We've also funded a number of regional projects, one at Newcastle, one at Sheffield, and Yit will talk about that, how we've extended the work that Phil's been doing in the urban environment via the Urban Observatory into a broader regional environment. Next slide, please. Okay, so some of our external partners, obviously, as you see from that list, we've engaged with a number of councils. Phil works very strongly with the Urban Observatory at Newcastle. Our sort of parallel organisation in Sheffield works with Sheffield City Council. In Oxfordshire, we work with county councils, Cumbria County Council, the National Park, Transport Scotland. We've also worked with engineering companies such as Siemens, who've been very supportive at with the programme at a programme level, and Jacobs, and you'll hear about some of that work later on. We've also engaged with a number of what I've called partner SMEs. So these aren't simply vendors, these are small technical companies that have worked with us very closely on the project, providing expertise on data, sensors, software, etc. So there's been a very strong interplay between the universities and these partner SMEs on these projects, and some of those will be mentioned later on. Also, outside our core work on the projects, we've engaged with what I've called networking partners. So, for example, the Integral project in Gateshead, we worked with Northumbria Water and Northern Gas Network. So here we had a 4-day innovation sprint workshop looking at ideas for the use of IoT in community energy villages and housing. And from that, we've developed some plans for future funding. And in Oxford, colleagues there have looked at Living Oxford, looked at the interplay between science and technology, society and IoT, very much in the way that Phil mentioned about that data issue. So as you can clearly see, we work with a number of partners. Next slide, please, Elizabeth. Right, this is just my summary of some of the academic disciplines that have been involved with these projects across the university. I may have missed some out, and some of these are my labels, so apologies for that. Phil has mentioned the Urban Observatory, so we work obviously we work in smart cities, air quality, traffic, people, buildings. As a sort of a mirror of that, there's the concept of the Rural Observatory, looking at extending that concept into the rural environment. So my colleague Yit will be talking about that later on. I mentioned biodiversity in connection with the Oxford projects. We'll hear about physical geography in terms of landslide monitoring. And also later on, we'll hear about Raj speaking about osmotic computing, which is, I guess, a means of sort of bridging the gap between edge and cloud computing. The two sections I mentioned at the bottom, management and social sciences and open living labs, they really touch upon the area that Phil mentioned about data, ethics, how does society interact with technology, specifically in the area of IoT. These haven't really been the subject of any mini projects, but they have underpinned everything we've done. And as I say, we've had several workshops on these areas, and there will be follow-on projects arising from these. Next slide, please. Okay, at the core of what we do are barriers to adoption of IoT. So these are barriers that we've identified in conjunction with our industrial partners, to an extent subjective, but what we try to do here is work with our partners, say, what are the issues that you're facing? What are the issues that you're grappling? What are the problems that you are having in deploying IoT? And these have very much been at the focal point of all our projects. I won't go into detail on this today, but we will have a report back at a program level in June, where we'll be looking at these sort of issues in more detail. So if you're interested in that area of things, looking at knowledge exchange and how we've engaged with industry to tackle these barriers, the June event should be of interest to you. Next slide, please. This is just my attempt to capture what we've done with these barriers. So on the right, on the left-hand side, you'll see a listing of the projects, and I've tried to map onto that the barriers that we've looked at. The detail isn't really important. I think the key point of this graphic is that there's a very broad distribution and spread of these barriers. There is some clustering around, for example, business case and technology maturity, which you might expect. But I think the key point is that given that these barriers have been developed based on the needs of our industrial partners and the issues that they're grappling with, they reflect a diversity of issues that our industrial partners are dealing with. And these are sort of the issues that we've tried to come to grips with in our projects. And I think you'll get a flavour for that in the talks that will come later on. Next slide, please. So, as I mentioned before, we have 4 themes: health and well-being, energy, cities, and manufacturing. And when we cross-reference these themes, these sectors, there are certain themes that arise. One of these has been low-cost IoT. This graphic I showed here is just from the internet. It shows, it's a classic technology cost curve showing how with time the cost of devices come down. This would be true of mobile phones, electric vehicles, solar cells, what have you. So what this means is that the opportunity for large-scale deployment of IoT sensors is increasing. And in some of our projects, we've identified this as a specific aim of the project, or a focal point of the project, rather. In other projects, for example, a project that you'll hear about landslide monitoring, I think low-cost IoT has developed as an outcome, an unexpected outcome of the project. So this is one example of a cross-cutting theme. As I say, this is the sort of program-level analysis that we're conducting now, and we present those sort of program-level meta analytical data findings at our conference in June. Next slide, please. So this is just a very high-level conclusion, a summary of the conclusions of our program. So as you'll see, we've had very strong industry-university collaboration with a very strong focus on knowledge exchange. We've engaged with a broad range of external partners. We've brought into play a wide range of academic disciplines. We've looked at a very diverse range of barriers to the adoption of IoT. Across all our themes, across our sectors, rather, certain themes common themes have emerged, for example, low-cost IoT. And as you'll see in the following section, many of our projects have produced a very significant impact on real-world issues and problems for the benefit of our industrial partners. Next slide, please. So as I say, in June, we have an event which will bring together common themes from all our sectors. And next week, for those of you who are interested, we have a session on manufacturing and IoT. Thank you.
Thanks very much. Thanks very much, David. Just strikes me that one of the questions that we might want to think on later is it's all very well having cheaper and cheaper sensors, but what about the skills gap to actually analyze and do something with that data that's being driven? That's something that perplexes me in the city as about how we address the skills gap with big data and those sorts of things. Anyway, something to ponder on. Let's jump into the meat of this, because these are the people who've actually been doing the work and coming up with new ideas and developing technology and concepts to address those. So we're going to kick off with my colleague, Tom Komar, who works in engineering at Newcastle as part of the Urban Observatory team there, talking about the adoption of computer vision and IoT. So I'll hand over to Tom.
Hello, my name is Tom Komar. I'm from the Newcastle University. I was involved in 2 computer vision related vision projects that were delivered in 2019 and 20. Next slide, please. Camera-based solutions in urban settings are a hot topic for at least 3 reasons. They raise privacy concerns, their processing, storage, and bandwidth requirements are high, and they employ use of artificial intelligence, which still is and will probably remain a very hot topic. Businesses that engaged with us and were successful with their submissions needed help in introducing new features into their existing product line of vending machines. And the other business required help in accelerating initial adjustments and operations of large-scale multi-camera vision systems. Next slide, please. The projects involved working with small businesses owners who expressed having the issues around dealing with GDPR and scalability of their products. We worked with their technical partners who manage businesses' digital operations and had very specific IT resources available. And where businesses' own capabilities were limited, they used specialist consultants or service providers to deal with details requiring advanced knowledge like training deep learning models for gender and age classification, or work-intensive tasks like installing cameras and networking equipment on lampposts. Next slide, please. The final outputs of the facial recognition project were presented to us as a live demo, showcasing how a small device that can fit inside a vending machine communicates observations from around the room, and an online API is presenting that information on a graphical dashboard. And the computer vision scaling project provided insights into attitudes to computer vision solutions from a variety of public sector clients. It has also produced a labeled dataset with over 10,000 images from a network of around 200 CCTV cameras. That dataset is available for anyone to download. And as part of the project, we have expanded our camera network that we now use for centralized processing of recorded footage. Next slide, please. The lessons learned from the project were to keep an eye on objectives that actually lead towards overcoming a barrier. So ongoing reporting and documenting progress in software and data development, and making sure that we're not focusing on details for too long or following outdated guides. Looking for ideal solutions can often lead to misplaced emphasis. The material outputs also need to be reusable, so that the created products or services have to be attractive, and generated knowledge should be applicable also outside the narrow scope of a project. Next slide, please. Small businesses concentrate on quickly putting together solutions that deal with problems at hand. Minimum viable products or first working prototypes, even if they mature over multiple iterations, is just one way of solving a problem, and it's advised to acknowledge or explore alternatives as well. Methods developed to deal with the challenges in retail or traffic applications may also be useful in other computer vision related IoT deployments if they are presented as solutions for the whole market, vertical or horizontal. Next slide, please. Thank you. Any questions?
Thanks very much, Tom. Tom, that was great. I mean, one of the things that Pitching tries to do was to have a number of small projects that led to greater things. And some of the work that Tom and the team did was taken up by the data science labs at the Office for National Statistics. And some of the outcomes were fed into a much larger scale processing pipeline to look at post-COVID response from CCTV. So I think that's a real demonstration of how these small projects have been used to seed fund potentially much larger and impactful things. Our next speaker is Dr. Luke Smith from Newcastle University. Luke's the co-director of the Urban Observatory in Newcastle and an academic in civil engineering, but before that he had some proper jobs as well, so knows some of this stuff as opposed to just wittering on about it like the rest of us. So I'll hand over to Luke.
Thanks, Phil. I resent the accusation that I've ever had a proper job. So I'm going to talk about the Chariot project, which is all about enabling local authorities, so local government and its various arms, to act as sort of arbiters of smart cities data. And this is work that we did in collaboration with a local smart city consultancy here in Newcastle called Urban Foresight. And the rationale for this really is local authorities both hold vast amounts of data, but also have access to vast amounts of data because of the relationships that they have and their numerous responsibilities. But it's a very mixed picture as to whether or not you can get access to that data, how real time it is, if indeed it is real time, the formats that it's in, and whether or not you've got enough additional information with that to really make sense of it. And to give you a sort of example with hard numbers on it, City Mapper, the transport app that you may have come across, it provides 130 million of economic benefits to people that travel to London, live in London, have anything to do with London. It benefits the government as well in terms of cost savings, but replicating that kind of thing elsewhere is quite difficult. In London, it's a little bit easier because TfL has more control. Elsewhere, there's a lot more private organisations involved. So this project was really about making data flow in an easier way in both directions. And sticking with that theme of transport, you know, if you want to find bus timetables, and if you're wondering why I'm banging on about buses on an IoT sort of event, well, buses are IoT devices. Your typical bus has 4 SIM cards in. Your typical bus stop probably has a SIM card in as well, and maybe a screen. So they are IoT devices. But if you try and find bus timetables, you go on data.gov.uk and search for it, you won't find it there. It is on gov.uk in a completely different system, in a completely different format, that unless you're a transport specialist will mean absolutely nothing to you. And the same applies in all manner of other sort of transport data. So public rights of way, for example, which you can't legally use for e-scooters or e-bikes and things like that. But if you're using them on foot, you have to go right the way back to the Highway Authority. Some of them have published it, some of them haven't. And some poor guy on a community website maintains the archive of all of these things. You know, he's just got a lot of free time on his hands. It's not a particularly sustainable way of publishing critical national infrastructure here. So this project really had 3 sort of big components to it. The first was to reverse the way in which we search for IoT data. So instead of you having to know what that data set is called, you would find it by knowing what that data describes or where that asset is. So it might be a lamppost, or it might be, there's some data about a bus out there. So that discovery and that cataloging is infrastructure first. It takes the assets and then relates them to the data. A standards-driven approach to sharing time series data. So again, sort of sensor feeds like temperatures from weather stations, that kind of thing, or asset tracking data in a way that is not the same for everything, because different IoT devices have different data, but in a way that has a consistent interface to it, at least, so that you don't have to rewrite the code every single time for a different type of device. And then the final part is guidance for publishers and local authorities to deal with the legal issues like GDPR that's already come up, data ownership. So if you're issuing a tender and you want to ensure that you can share that data afterwards, how do you go about that? And ensuring that you get reasonable quality data, because obviously IoT devices vary massively. It's not always going to be Rolls-Royce data. So what we did to enable this is we've published a whole sort of suite of software tools, some of which were based on the work of the urban observatories. So there's a link to data APIs that are intended to facilitate this data sharing. And there will imminently be released a front end that allows you to search for that in the same way that you can on sort of DataGov UK. And then the final bit of the project is that guidance and the toolkit, which is written documentation that local authorities can read, and with some case studies from probably across the entire wealth of pitch-in smart city projects based on our experience of how to make these things happen. One example of a system that uses that very code and that very technology is a smart building here in Newcastle. It has roughly 4 billion records from every single room in this building. So the code is reasonably battle tested. We know that it can handle large volumes of data. And also the types of data vary massively as well. Some of it is sort of simple time series, but some of it is a matrix that describes the size of the rainfall droplets and other obscure things that, if you had a brainstorming session, you would never have thought we were going to be storing that. And then the final component to this project that we're going to use this system for is a couple of demonstrators. The first is a mobility as a service app in Scotland around Dundee. So ride sharing, public transport, bike hire, all of those things will be available. But the technology that integrates those different private providers together will be based on this. And then here in Tyne and Wear, Citymapper, as I already mentioned, the Newcastle was recently added to the Citymapper app, but it's a bit rubbish at the minute. It's a bit lacking. And we're gonna work with the 3 bus operators here, the Integrated Transport Authority, and the Department for Transport to pull all of that data together, but also all of the context that goes with it. And because of COVID, also data like how many people are on those buses. It will all be available from a single location, from a single standard. And then just some final thoughts from me. The idea that data sharing and open data should be someone's entire job and a laborious process is the reason why a lot of this data is hard to find in the first place. So in an ideal world, and one of the things that Chariot aims to help people do, you have a single system that you use for your internal data management that maybe maybe there's a greater a more extensive data set that you allow access to internally, but it's the same system that you then make available publicly. It's the concept of dog fooding. You're eating your own dog food, which is a lovely thought for everyone on this afternoon. And that means that the data will always be up to date. Not everyone wants incredibly complicated code and APIs and things like that. Some people just want a spreadsheet, and that is absolutely fine. But the businesses and the IoT users that do this for a living, they do generally want APIs. So you need to target both of those things we need the applications at the end that can make use of that and make it understandable for the average everyday person if necessary. And then the final thing is, like I already mentioned, potential third demonstrator around sort of safe recovery from COVID, getting people back onto the buses and things like that, which wasn't really part of the original plan for this project, but because everybody is terrified of public transport at the minute, we've got a little bit of funding from MHCLG to look at that in more detail. That's the Chariot project. I'll leave it there.
Thank you very much. Thank you very much, Luke. Our next speaker is from Sheffield, Dr. Oktay Cetinkaya, who's going to be talking to us about radio frequency systems performance. And it's really interesting that you can have both high-tech issues with comms networks, but also low-tech issues. Some of you in Newcastle may remember the helter-skelter that appeared in the middle of Northumberland Street a couple of Christmases back, or during November, I think it was, which managed to take out most of the CCTV network in the city because it cut the microwave link. So sometimes communications challenges can be low-tech as well as high-tech. So I'm really interested to hear this next one. Over to you, Oktay.
Thanks, Phil. So, hi everyone, I'm Oktay Cetinkaya, Research Associate at the University of Sheffield. So today I will be talking about RF systems performance in smart cities. Next, please. Yes. So let's start with the problem. The problem, or the main challenge, is the rapid global urbanization, and so the ever-changing urban landscape due to the proliferating numbers of buildings. So what we are having is, of course, those inevitably affect so many things around us, but most notably the wireless network. Because when wireless signals pass through objects, such as walls and windows, they become weaker due to the reflections of or absorption by these objects, which often refers to building loss. Besides, the wire mesh in these buildings act as a Faraday cage, which prevents RF signals to pass through. So in cities where tall structures or buildings clustered together, signals are not only blocked by concrete and metal, but also collide with each other in the canyons between these buildings and skyscrapers, which weaken the signal. And with the increasing population, we are actually adding more and more mobile cellular, Wi-Fi, and IoT devices, and we are giving more and more critical paths to these devices. But there is one thing we definitely disregard, which is the RF spectrum. So the current spectrum is suffering from overutilization, and as I said, we are just giving more pressure on it. So what we need to do is we need to measure interpret and understand how the current spectrum is working and what are the detrimental effects of global urbanization and how to tackle it. Next, please. So the project is about, again, modeling, mapping, and maintaining reliable and extensive coverage across the Sheffield City region. This includes mobile cellular, Wi-Fi, and IoT networks, of course, and we have to gain an understanding of how the ever-changing urban landscape is affecting our RF system operation. So imagine structuring a whole building just side of a base station or an access point. So how this RF signals that we don't see is affected by this building. So, and also in considering the increasing demand for IoT applications, we built a reliable LoRaWAN gateway architecture, where you can see on the top right figure. So we deployed 8 LoRaWAN gateways across the city. And I couldn't put the figure here, but we provided roughly full coverage over the city. So this provided the platform for anybody living in Sheffield to build their own IoT applications on top of the infrastructure we offer. So, and to map the networks, we used the devices that you see on the bottom, most of the autonomous network scanner, and also the GPS trackers for the LoRaWAN gateway. So we walked around the city, we drive by around the buildings with the observatory on electric car. And the main goal is, again, to understand how the buildings, the materials, and this urban landscape is affecting the RF system operation, can we actually optimize it by relocating some wireless components or adding maybe more and provide a reliable operation? Next, please. So we started with a scientific and real literature report to highlight the impact, again, the material and building loss and to the wireless propagation, so which was broadly neglected by the literature. Then we, after we deployed our gateways, we actually probed the environment and mapped and did some surveys and provided a highly granular IoT network coverage map, as you see in the figure. So we collected around 20,000 data points and provided a city level coverage map. And with this, with the surveys, we became confident about the sources of signal fading in urban places. And based on this, we provided and offered some solutions, potential solutions and necessary actions to be taken to address the shortcomings of these things and hopefully offering a reliable and efficient wireless network operation. So we extended our work by 2 months with a small funding from UTRA, where we focused on buildings and indoor modeling, as well as the city-related work we are doing with kitchen study. Next, please. So lessons learned, we collected enough amount of data to understand the performance of the existing wireless infrastructure, as well as the emerging networks, and also the wireless LoRaWAN infrastructure we built. We did 3D modeling and simulation work. Actually, it all started with the simulation study because we couldn't start our experiments with the COVID. So we used a 3D ray tracing based network planning software called Runtime Wireless, in which we realistically modeled building, not only building, but also the city of Sheffield in the 3D space, and run simulations trying to understand how we can enable, how we can understand the operation again, and how we can actually make it better. So based on this empirical study and also this based on simulations, we determined, again, the factors and the factors of signal attenuation causing poor coverage or dead spots in the cities. And we shared all our results with our stakeholders, which is a long list of 50 collaborators. We disseminated our results at 2 Sheffield IoT meetup events. The last one especially was quite useful because now we are collaborating with an industrial partner of ConnectSynth on this LoRaWAN gateway architecture and also associated sensor applications. We are working with colleagues from Triple department and also civil engineering on how we can extend this to another application. And also we have already one journal paper, and now we are about to submit a conference one and hoping that to reach a wider audience on this topic. The next one, please. So the next steps will be on collaborating in collaboration with Banza DMCO. We will investigate indoor wireless performance by doing both experiments and also 3D modeling. We will work at the University's iCare Center to do specific material characterization tests to understand again the building loss and effects and the organizational effects in cities. And we will extend the IoT coverage across the rural areas as well, not the city center. For example, to pick the City National Park, we have already started circulating ideas and a potential proposal on this. And finally, you see some buttons at the bottom. So these are the potential areas we want to extend our study. So if you are working on this topic, we have pretty nice ideas. So we would like to collaborate with you. Please just reach us. And I think that's all. Thank you very much.
Thanks, Oktay. That was great. And as you'll see later on, there's a lot of overlap with some of the work being done in rural Northumberland and IoT. That there should be a good degree of cooperation. And for those that don't know as well, Newcastle, the Urban Observatory in Newcastle, Newcastle University, and the City Council have collaborated in. We are just in the process of deploying a LoRaWAN network throughout the city here as well. So that's available for IoT applications for those that want to use it. Okay, our next speaker is my colleague from Department of School of Computing Science at Newcastle, Professor Ranjan. And I'll hand over to Raj, who's going to talk to us about osmotic computing, which was a term that completely blew my mind when I first came across it a couple of years ago. Over to you, Raj.
Can you hear me all right, Phil?
Absolutely, loud and clear.
Thanks, Phil. Thanks, Phil and David, for inviting me. So today I'm going to talk about the small project that we did funded by this Pitch-In initiative. So our project was Osmotic Mindsphere, air quality modeling in the IoT and Edge. So the main goal of this project was how do we program complex IoT application in an environment that consists of systems of systems. So by that I mean we have a system where we have a cloud computing layer, edge computing layer, and the IoT layer. And we somehow, as a computer scientist, need to come up with programming paradigm that enables or simplifies people like Phil James and Steve and others to really able to manage the life cycle of data analysis applications such as air quality, flood modeling, landslide, or you name it. So to solve that problem, along with my colleagues, European colleagues, we came up with this paradigm called osmotic computing. So the basic idea behind osmotic computing is how do we use the microservices and container-based programming primitives to simplify the runtime management of IoT application in this kind of a hardware and network environment where we have cloud layer, edge layer, and IoT layer, where there heterogeneity in the resource types, and also as other speakers mentioned, there's a heterogeneity in the network comms. So that's the whole idea behind this project, that we had already ongoing development on osmotic computing framework, and now we wanted use to show an impact in the air quality modeling area. So that was working along with Newcastle City Council and Siemens and Software AG. So that was our impact story behind this project. So as I said, the main challenge was in this kind of multi-layered environment, system, how do we manage the runtime complexity of network comms and the resources? How do we orchestrate the data flow right from the IoT sensors all the way to the environmental models for air quality or landslide? And of course, some of these applications are safety critical. So how do we ensure low cost monitoring and troubleshooting if something goes wrong with the infrastructure as well as the software platform? So that was our main challenge scope. And to solve that, we developed this osmotic computing paradigm along with Siemens and City Council. So as I said, our main industry partners were Software AG, Newcastle City Councils, and Siemens. And the main features of our Osmotic Mindsphere orchestration platform was automatic data flow orchestration and deployment of models across the edge and the cloud layers. And we also supported infrastructure level monitoring and maintenance to troubleshoot the problems that happens as you are running and deploying your applications. And so what did we achieve as part of this funded project? We have implemented the Osmotic platform, and we have demonstrated how to run air quality modeling using that platform. So you can find the source code if you want to use it on this GitHub link. As you know that in this kind of complex environment, if you want to optimize the performance of application, it's not really easy to experiment with multiple parameters on a real infrastructure such as urban observatory. And however, in this IoT application scenario like osmotic computing, we do need to play with different network comm times, different resource configuration. And to do that, the real infrastructure is not a good approach. So to solve that problem, as part of this project, we also developed something called IoT Sim Osmosis platform, which is a discrete event simulation engine, where you can model infrastructure such as urban observatory, and then you can experiment with different network comms, different kinds of faults and failures and resource features, and then you can study in this kind of environment, if I program my application, how is performance going to look like in terms of response time, throughput, and other performance profiles. If we have also released that software code that you can find on the GitHub link given below. So these are the two main outcomes that we had as part of this project, this funded project. Along with Phil's team, we also had a couple of publications. Some are accepted, some are under review in conferences and journals. So what did we learn from this project? What we learned from this project is that what we developed called Osmotic platform is quite generic. So of course, our current demonstrator is for air quality, but we also using the same platform with Phil for other project in flood modeling. And because we use the container-based paradigm to program our application, our approach, our middleware can be used to port any IoT data analysis application in this kind of environment. And going forward, we are going to seek more funding to enable other applications such as supply chain management, electrical vehicle scheduling and routing, and so forth. So for those two areas, we have received almost £2 million from EPSRC to work on that area. So we are going to apply our framework to solve those problems as well. Another thing we are pursuing with the Newcastle Urban Observatory is we are wanting to work with Software AG, Siemens, and Newcastle City Council to develop some ref case studies. Of course, for not this one, we are too late for that, but for 2027 and 2028. Many thanks for inviting me, and I'm very happy to take any questions if there is some time.
Thanks very much, Raj. If people want to put questions in the chat, there's some fairly lively stuff going on in there anyway. Please do, and we'll try and address some of those at the end. Going to jump on to figuratively rather than literally to my colleague, Dr. Rupert Bainbridge from the School of Geography here. Looking at the other end of the spectrum, from the application end of the spectrum, rather than the back office end, if you like. So I'll pass over to Rupert.
Hi there. Yes, I'm going to talk about application of sensors for managing hazardous slopes, particularly in sort of rural environments. And I also did this with a couple of colleagues, Dr. Stuart Dunning and Dr. Alejandro Diaz Moreno. Next slide, please. So the challenges we really faced, basically landslides pose a real risk to road users and to critical infrastructure. These roads are critical for linking cities with the wider regional communities. The pictures you can see at the bottom are from a road which is maybe 40 minutes outside of Glasgow in Scotland. So, you know, really these roads are servicing sort of communities, getting to cities and getting to towns, and it has a real impact if these roads are closed or damaged by landslides. Next, please. So the monitoring of these sites, key high-risk sites, this one in particular is the Rest and Be Thankful in Scotland, requires a lot of labour inputs at remote sites over a long period of time. The road was closed for about 150 days last year. So it was closed for a very long time with personnel on site constantly as well. Next, please. And so the barriers that we face in terms of monitoring these sites, particularly with labour, but then also with how do you start to integrate the use of sensors into the current stakeholder decision-making processes that are already there. Next, please. So the project that we were trying to do really was to trial and implement some new technologies which stakeholders weren't currently using to manage the roads more safely, and sharing useful real-time information from IoT sensors with road management stakeholders. We were working primarily with on the Scottish Trunk Road Network, working with Transport Scotland initially, but this led to collaborations with Bear Scotland, who also subcontract out to Jacobs and Georope working at this particular site. But we were also working partly with Cumbria County Council, trying to look at some of the embankments that they have and the stability of those embankments on the road network. Next, please. So I'm going to focus mostly on the Scotland one. There was a reason for that. The Cumbria work was very impacted by COVID, and I'll come back to that in a bit. But in Scotland, we had a sensor network. Part of pitching was to create resilient communications with that sensor network in a very remote site. So we have Wi-Fi communications in that service a number of components on different sides of the valley from where the road is that we were monitoring. This is also backed up with a satellite link if various communication methods go down. The Wi-Fi then comes back to a 3G connection, which delivers the data back to Newcastle for processing. So this network is servicing a number of instruments which are monitoring the slope. We have, for landslides, we're really interested in trigger mechanisms. So rainfall is the main trigger mechanism we're interested in. We're interested if there's any precursory movement or when movement actually occurs, which the data is given to us by a time-lapse camera. Time-lapse cameras are optical, so don't always work well in cloudy or rainy conditions. And so we were also working with seismics, trying to look at very small Raspberry Shake or Raspberry Pi enabled seismometers that would allow us to sense landslides have happened outside of sort of when the optical systems were working. So in terms of the rainfall, this data now comes back. We were very interested in getting all of this data back in real time and being able to give stakeholders data in real time. So the rain gauges, we're now processing rain data in real time and providing indications as to whether rainfall is at a sufficient rate or there's been enough rainfall that we're in high risk of landslides occurring. We use the time-lapse camera data. We're actually doing real-time deformation tracking on the time-lapse camera, so we can look at consecutive images, look at the differences between those images, and tell road management authorities if we've detected if something is moving on the slope or whether something is continuing to move, how far it's moving, what sort of rate these things are moving at. And this has been very useful in terms of whether the road has been open or closed, and which areas of the slope they're really concerned about. Maybe there's going to be a landslide. The seismometers, we're still in development with the seismometers. They've been quite difficult to get the data back, but it's work in progress, and we have actually detected debris flows on the seismometers, which we've been able to link the timings with the time-lapse camera data as well. Next slide, please. So the lessons that we've really learned, these sensors are very useful for real-time monitoring of road infrastructure that is at risk of landslides. The communications have really been the problem with the adoption. You know, the stakeholders really need these reliable communications, which we've been able to provide. The time-lapse camera is now an operational asset that Bear Scotland are using for monitoring this site, and the rain gauges are being regularly used by Jacobs for determining landslide susceptibility at the site as well. And it was very important for us to identify the key stakeholders. Different data streams are being used by different levels of the stakeholder hierarchy. You know, Transport Scotland aren't necessarily interested in it, but Jacobs really are interested in it. Next slide, please. So the next steps, we really need to upscale this to various other sites. Transport Scotland have identified other sites as well. Next, please. We've got this Cumbria embankment study, which is very COVID disrupted, which we're going to hopefully pick back up on as well. That's using small low-cost GPS units. We want to engage with other industry partners as well, whether it's on the rail lines or hydroelectric dam constructions as well. Next slide, please. Sorry for going over a little bit there, but that's, yeah, thank you very much for listening.
Thanks very much. Thanks very much, Rupert. really interesting, and there's obviously lots of common themes emerging that maybe we'll get a chance to talk about in a little while. Our final speaker, but by no means last, is Professor Yit Arn Teh from the School of Natural and Environmental Sciences here in Newcastle, who's the co-lead on, on Hinterland, which is looking at moving IoT from the cities into the rural areas, which other people have also talked about here. So there's lots of crossovers with Rupert and Stuart's work, and also the work in the Peak District. So I'll hand over to Yit, who's going to talk to us a little bit about Hinterland.
Thank you. And I just wanted to acknowledge that I'm really here sort of speaking on behalf of the team that I've listed below. And you know, Ellen was the postdoc working with us who actually kept us all in line and made sure we did the right things at the right time and helped sort of coordinate all the logistics. Next slide, please. I think, you know, this is slightly outside of, you know, the original scope of cities, in the sense that it's not necessarily an urban project. But I think part of why we proposed it was because there's this, you know, there's a recognition that cities are interconnected into their regions, whether in terms of activities, you know, people going walking, tourism. That's been especially apparent during COVID, where people have wanted to get out of the urban environments just to experience a different type of environment. They're also connected through our various sort of economic and production systems, whether that's food, you know, there could be industrial parks and so forth that are located outside of city centers and sort of suburban, peri-urban areas. We're also becoming increasingly concerned as citizens with things like the impact of our urban, suburban, and sort of rural development on things like biodiversity, climate change, impacts on pollution, you know, carbon, water dynamics, and so forth. Our growing awareness of our kind of responsibilities towards managing sort of resources in a more sustainable way. And one thing we recognized quite early on is that even though there's been quite good uptake of you know, IoT and sort of connected cities, you know, within the urban environment, the sort of wider awareness of these technologies outside of that context is much less. So even though there might be sort of lots of academics using sort of sensor networks and so forth to do sort of more academically oriented research, we're thinking here more of sort of our end users, stakeholders, farmers, people that are interested in tourism, conservation organizations, or land and resource management groups. Those sort of practitioners who may not have as much expertise or knowledge or wider awareness of sort of some of the technological opportunities. And to, you know, and I think that's the real point here, is that there's a big opportunity, partly from, you know, because there's a sort of deficit of uptake and use at the moment. Lots of opportunities in managing sort of, say, agri-food systems, challenges with sort of resilience against climate extremes, facilitating you know, improved management practices, whether it's you know, increasing our capacity to sequester carbon or reduce pollution. All of these kinds of factors, these are things that we can use some of these sort of IoT systems for, but it's really important that it's developed within a context where the systems and, you know, use cases are developed with the stakeholders in sort of a participatory way, rather than sort of independently, you know, in the academic community. Next slide, please. So what we've done in this case is it's a sort of a cluster or a series of different projects where we've tried to showcase the benefits of some of these sensor networks for non-academic stakeholders by developing a number of testbed or demonstrator sites. What we would like to do is, within the wider context of Newcastle and sort of the N8 and so forth, is lay the basis for what a number of people have been calling the Rural Observatory, sort of an integrated sort of environmental monitoring system that could, you know, could address some of these multi-dimensional needs, everything from, you know, biodiversity management through sustainable land, sustainable farming. And a key thing to this project is that it was really focused around engagement, work, and sort of participatory research, developing these testbed sites with our partners. In this case, Northumberland National Parks, Heppel Estate, and the NU Farm and the Newcastle University Farms. Next slide, please. So to briefly run through some of the main projects that we set up, we've been developing a project at Hadrian's Wall with Northumberland National Parks to look at how humans use rural sort of tourist attractions in this case, and deployed people counters along that. We've got most of our investment really in terms of time and effort really has been at this at Heppel Estate, where they're sort of conducting a rewilding project. And we have a number of different things that we've set up, everything from monitoring animal movement. We've got a kit for looking at pollinators and microclimate. And finally, we've set up some initial setup at Nafferton Farm to look at water balance and water cycling. Next slide, please. And what we really found that was interesting is that I think there were a lot of really useful insights about the sort of the mode of working and the mode of engaging with stakeholders, how to interact with them, how to identify needs and so forth. And that requires sort of quite a long-term investment in terms of time and developing a working relationship where communication, it functions well, and you're able to work together as a team. Other sort of more practical things is that I think for a lot of the kit that we used, it was often found to perhaps not be as robust as we'd like, and so I mean I think there's it's just sort of a very practical consideration in terms of that modifications and so forth might be necessary to kind of make these sort of off-the-shelf bits of equipment a bit more robust, fit for purpose, able to withstand the lovely weather that we have here in the Northeast. Next slide, please. And what we're planning on doing next is we'd like to continue working with our stakeholders. So we've set up these test beds, partly because of COVID and some of the delays with procurement and so forth. We're only really starting to have some of the data sort of coming into us now. So we don't have results as such to show at this point. But there's this legacy, I think, in terms of moving forward into the future, that our stakeholders will continue to use this kit and continue to work with us. I think what we're interested in sort of securing more funding to kind of expand the kind of work we're doing, and I think what we've set up so far forms a nice basis for that. And in terms of the engagement side, I mean, I think it's really clear that everyone recognizes how important and novel, timely these kinds of IoT networks can be. But I think there's a real deficit in terms of skills and capacity. So I don't think we can necessarily assume that even if we could produce, some nice sort of user-friendly piece of software, that we could just deploy that as sort of a commercial product or something. I think some of the complexity with some of the data and so forth means that there may be a required ongoing sort of need for that interaction between researchers and our researchers and stakeholders. And a final slide, please. I think it's just the thank you slide next. And I think I'm just out of time, so I should stop there. Thanks.
Thanks very much. Thanks very much, Yit. And I mean, Yit's doing a disservice to the project a bit, because I thought one of the startling outputs from pitching was, although there was this massive rewilding going on, the ponies that we were monitoring through GPS collars only used 8% of the land area that was available to them. So it tells you something about, what they were finding interesting and where they wanted to go. They had all of this space and they didn't use much of it. They stuck to very familiar areas. So, even at early stages, there were some great insights.
Yeah. No, and I think there was that, and the extent to which they were reacting to humans, we could sort of see, and that plays into questions we have about, in terms of animal behavior. If we're going to, with things like ecotourism or something, how are we going to affect the behavior of these sort of wild or, or even partially domesticated animals and how they respond to us, because it can have consequences for their reproductive biology and other things. So it is important. Yeah.
We've probably only got time for one or two questions at most. So I wonder if the panel, the speakers could unmic themselves. And the question I wanted to ask, which has sort of come up a couple of times, and I think Yit touched on it there, was around, and maybe just some reflections from different panel members on data quality. You know, one of the issues with IoT equipment is it's either perceived as perfect when we know it's not, or it's often it's of poor value because of the data quality and how that challenge might be addressed in future. Does anybody from the panel would like to respond to that? The resounding no, obviously.
I guess this is one thought I'd had, and so I'm really not technical at all, so I'll just say that up front. But something I think, and this sort of applies to non-IoT projects as well, is that I think, and just dealing with sensors in general, is just I think the front end, the amount of care that you have to take to sort of test your kit in terms of data quality and so forth. I mean, I think this is an issue that we have with other projects that aren't necessarily IoT, but the specs aren't necessarily the performance in practice. So I think some level of, but there's a lot of other stuff with sort of gap filling and sort of data quality management.
And Raj, do you want to come in on that? Because I know you've got some experience in dealing with these high velocity streaming networks and how we can manage them.
I think, as you said, I posted one new paper on Twitter on sensor data quality modeling, and we have modeled that. But the lesson that we learned from working with different applications with the team is data quality model changes based on what application we have. So the main parameter, like how fresh is the data, how accurate is the data, what is the precision, it always depends on how safety critical is your application, because some application, like transport modeling, you can do with historical data, and the data quality is not that strict as long as data is correct, right? But if you're using IoT to detect cyber security attacks, then in those things, data quality becomes really, really safety critical, because you cannot detect a real-time attack using historical data. So the issue here is we have to talk to different industry partner and application owner and see what data quality means for them and how much tolerance they have on the age of the data accuracy and precision. So it's all, I think, application by application specific. So that's what will tell us what data quality is. But how do we solve the problem? We have to look into AI-based approaches and deploy in your urban observatory to try to retrofit the data if something goes wrong. So that would be the solution, and we should be working on those kind of EPSRC bits to solve those kind of problems. Yeah.
Okay, thank you very much. We're sort of out of time, which is a bit of a shame, because I think there's a rich discussion that we could potentially have. I think one of the reflections that I'd like to finish with is around, and I think a number of the speakers have touched on it here, is that, as I said in the opening remarks about how do we, one of the problems with demonstrating societal benefit is that the value proposition for this data is spread very thin. Lots of people potentially benefit from greater understanding or having this data, but it might not be business critical right now, which means that the maintenance of these systems, which as a number of people have touched on here, is pretty hard. And in some cases physically demanding if you have to walk up a mountain to go and flick a switch to switch your LoRaWAN gateway back on, for instance. And I think there are real challenges moving forward for IoT about how we maintain, how we demonstrate the value proposition whilst we're still in this, we still haven't quite hit that curve, that exponential curve of data coming in. I would like personally, and on behalf of Pitchin, to thank all of our speakers for speaking, but also being involved in the project. I'd really like to thank Sheffield University and some of the team there who've helped put on this event and managed it all very well. I'd also like to thank the Cities New Core, the Centre for Research in Cities at Newcastle, who've co-sponsored this event. And just a round of applause. Thank you for attending, and thank you for all of our speakers. So a virtual round of applause. And next week, we could potentially do this in real life and meet up and have a beer. And I'm really looking forward to being able to do that and talk to some real people other than a screen. So thank you very much for everyone who's come. And just a reminder of the events next week and the pitching conference in June if you're interested in coming along with that. So thank you very much. Thank you very much indeed.